Okay. So first, introduction from myself. I am Jyoti Pal, fifth year research scholar from IIT Kharagpur, and you already know about this course that you are enrolled in. It is the Introduction to Polymer Science, and it is conducted by Professor Divakar Dhara, and I am the PMRF TA of this course. So we have this live session every week, Tuesday from 7 to 9 p.m. So mainly what will happen in this live session is we'll discuss some question, like I will give you some questions to solve, or first if it's some kind of theoretical questions or some MCQ, then I will probably give you 2 minutes to solve it, and you can give the answers in the chat box. After 2 minutes I will check the chat box and see what answers you all have given. And in other cases, like if it's a numerical, then I will give you additional time, like 5 minutes or 10 minutes according to how long it is, and then you will give me the answer, what answers you are getting, and then we'll check the solutions together. Okay, so before we start, I want to know something. What was the date of your assignment, last date of your assignment 1 submission? Is the deadline over? Can you let me know in the chat box, please, someone? What was the assignment 1 deadline? Assignment 1 submission deadline? 9th August. Okay, so it is still running. You guys can still answer. Then I can't show that those solutions to you. Okay, so fine. Let me try to share my screen. Okay, so can you see the presentation? Someone unmute yourself, and I can then check it. Is the presentation visible? Okay, someone just replied yes. Okay. Okay, so there are still many people who are joining. 1 second. I think there is some problem with my internet connection. Okay, I think so. There are 41 students. So let me start, and then who wants to join. Assignment problem. Yes, we will have problems similar to assignment problems, so that you can easily solve the assignments. Also, the question that I'm going to discuss will be helpful for you, for whoever is taking the examination. Maybe not all of you are taking the exam, but it will be helpful for everybody to just understand the course, and whoever is taking the exam, that will be helpful for them as well. Okay, so it's 7:10 already, still people are joining. So from next class, please try to join by 7:05, so that I can get to the questions quickly. And again, this is a 2-hour live session, so it's a pretty long live session. So first, in the first half, okay, someone please stop presenting. Okay. Ahidul should not present. Try to present now. Okay. So there are still many people. So no, please, somebody else don't try to present. I am already presenting, so you will not be able to see it in that case. Keep your microphone off, keep your videos off. You can ask your questions in the chat box. I will see it after 1 hour and I will try to resolve all your queries. And if I don't know, I will read them and then will come back to you in the next session as well. Okay, so there are still many students trying to. Okay, okay. uh, so I am starting to present. So this is the first lecture. The lecture 1 was mainly about the historical background, that how polymer was invented and what were the thoughts of the scientist, how actually it was accidentally invented kind of. So, and some basic concepts about polymers, molecular weight, degree of polymerizations, etc. So we will try to solve the questions related to those things first. So this is the first question. This is just a MCQ question. I will just give you 1 minute, and after that you all can write your answers in the chat box. I will check it and then I will tell you what is the right answer. Okay. So this is the first question. This states that the concept that macromolecules can be formed by linking a large number of small molecules by means of covalent bonds was first introduced by, and then there are 4 options. uh, Please write down your answers in the chat box and after 1 minute I will check it. Okay, and please, others, please mute yourself or it will be problematic to for all of you to hear me. So this was the first question. So many has written B. Okay. Okay. So let me go back to the question. There are many people still wanting to join. Let me admit them first. And everybody please mute yourself. I am requesting to all of you. There's some problem with my net, I guess. Okay. So let me go back to the slide. Okay. So the answer B is correct. The option is Schrodinger. So what happened that he first proposed, even without the idea, I mean any experimental proof, he assumed or he believed that polymer molecules are formed by forming a covalent bond between small units. Okay, before that I think Professor Dhara has already discussed these things as well. Just let me briefly tell you all. Okay, so please keep yourselves mute. Okay, so what happened before that, people used to think that any kind of macromolecules, they are kind of formed by small molecules as well, but not by covalent bonds, some kind of non-covalent interactions. Okay, just like surfactants and etc. Like the surfactants form those micelles and everything. People used to think that the macromolecules are also formed via this way. There is no bond present between those units. Okay, they are covalent bonds. So that they used to believe, and by that time Schrodinger did not have any experimental uh, results to prove that. Later, by the help of Carothers and Mark, by these scientists, because of their experimental proofs, he gets a Nobel Prize, and he was right about that the polymer is or macromolecules are formed by the covalent bond between small molecules. Okay. So let's move on to the next question. Okay, so this is the question. It is written that a polymer was synthesized as it is shown here. It is a reaction between adipic acid and hexane diamine, and we are getting our nylon 6,6. This is the polymerization reaction. So the question that is asked here is it is the polymer can be classified in terms of polymerization mechanism. First you have to identify that what is the polymerization mechanism, and second, on based of the reaction product, that what is the type of this polymerization, whether it is step growth or chain growth, and whether the reaction is condensation or addition reaction. Okay, so I will give you 2 minutes to figure it out, and then we will look into the solution. Okay. You can also write your answers in the chat box as well. I will go back and check it out. Just think about the properties of step growth and chain growth polymerization, and what are the main difference between condensation and addition, and you will be able to answer this question. Let me go back. Answer is A. Someone has written condensation. Just write the answer, because there was 2 questions. Type of polymerization was asked as well. Okay, so let me go back to the slide and give you the answer. So this was the question. So the correct answer is A. So why it is A? If somebody has any problem with this kind of question, let me explain it. Okay, so the first question is whether it is step growth or chain growth polymerization. So we first have to think the major difference between the step growth and chain growth mechanism. So the main thing is, in case of step growth, we don't need any initiator, okay, or where the radicals will be formed. Okay, so step growth reaction occurs via the reaction between two functional groups, whereas in case of chain growth we need an initiator which can provide the radicals. Okay, so in our case there is no radical formation here. We don't need an initiator for this case, but we have these functionalities. There is this COOH group and this NH2 groups. So these two functional groups can react with each other, because NH2 will react with COOH group to give our amide bond formation. So the whole reaction is happening via the reaction between two functional groups. So the correct option should be step growth polymerization. Coming to the next part, that whether it is an addition reaction or a condensation reaction. So what was the major difference between these two? In case of addition reaction, we know that there is no generation of small molecules. Okay, but in case of condensation reaction, generally a small molecule is coming out from the reaction. So here, if we look at the reaction, we have a small molecule here, H2O. So obviously the reaction is condensation. So our correct answer is tape growth polymerization and condensation. Okay. Let's move to the next question then. If someone has any queries with these problems as well, they can write in the chat after 1 hour. Okay, after 1 hour, when I will give a 10-minute break, during that time I will check your queries so that I can answer them again. Okay, so this is the third question. The amorphous domains of a semi-crystalline polymer sample are responsible for, the options are, first option is glass transition temperature, second one is melting temperature, C is neither glass transition or melting temperature, and D is both glass transition and melting temperature. Okay, so I will give it 2 minutes as well. Just give it a thought and try to answer it. Okay. You can put your answer in the chat box. Meanwhile, let me admit others who are trying to join. TG glass transition temperature. Okay. Two of them have answered this. Okay, A, TG. Okay. Others also please give it a thought and then I will discuss. Okay. So those who are joining late, an instruction again for them to please try to join by 7:05. Otherwise, you will miss the questions as well, and I will. The meeting will also be delayed. Okay. So let's go back to the question. Someone is again trying to join. I will let you join later. Okay. Okay. So the correct answer was glass transition temperature. So why is that? Sorry. 1 second. My pen is not working. Just wait a bit. Okay. I think now it should. Pointer option. Okay, so the correct answer is glass transition temperature. So for this question, we first need to know that what is the, why, in what cases Tg arises and in what cases Tm arises. So the name melting temperature is actually generally are denoted for the crystalline molecules. Okay, any kind of crystalline product, we get melting point for them. So what is the difference between crystalline and in case of these polymers? So crystalline means there is a order between the molecules. Okay, so I cannot write this properly. So there will be some straight lines like this. Okay, this should be straight lines. I cannot draw straight lines currently. So this is in the case for crystalline molecules. So for them, we will get melting temperature. But in what cases we get the glass transition temperature? So glass transition temperature, we can think it is as between crystalline and amorphous state. So in case of polymers, what happened, the polymers are large molecules, so to form a crystalline state they have to be in order, okay. But for polymers, as the chains are very huge, so it is very difficult for them to arrange in a specific nature, so it will be very difficult in this case. So what happens in most of the polymers, there remains both the state, like some part of it will remain like this remain in this unordered state, which will be denoted as amorphous region, and there will be some regions where they might have maintained some amount of orderliness. So these places will have this uh, crystalline nature. So what happens when you increase the temperature for this whole system, the whole system transfer from the semi crystalline state to a amorphous region, because you are increasing the temperature, so the whole orderness will be hampered. So whatever semi crystalline type of regions were there previously will now no longer be there. So that particular temperature, when we are moving from a semi crystalline state to a glassy state, is called the glass transition temperature. So as the polymers except a few like proteins, I mean DNA, RNA, etc., all other polymers doesn't remain in a proper crystalline state, so we cannot state that they have a melting temperature. So what they will have a TG. Okay, so this is the third question. Let's move to the fourth one. Okay, so this is the fourth question, and this is an easy one as well. So it states a polymer has the following schematic structure, where red and green circles represent structural residues from two different monomers. That means the green balls that you are seeing, they are one kind of monomer, and the red ones are different kind of monomers. So now they are asking whether the polymer can be described as a block copolymer or random copolymer, alternating copolymer, or a graph copolymer. Okay, this is the question. Read it and try to answer it within 1 or 2 minutes. I will see the chat box as well. Okay, many people are saying B, random polymer. Okay, okay, B, okay, B again. Okay, so most of you are answer as is B. Okay, let's go back to the question. Okay, so the correct answer is B, random copolymer. If anyone is confused, then let me discuss it with you. Just give me a second. Some people are trying to join. Let me incorporate them. So again, it's a request to all of you. Please join by 7:05. Otherwise, you will be missing questions, and I have to continuously admit everybody. That is fine by my side, but you will all you will miss many questions by that time, because it's already 7:30. Okay, and don't worry about the long class session. I will give you a break. No one can take or do a class for 2 hours straight. and there is a problem. Okay, let's go back to the question. Okay, so why it is called a random copolymer? If we look into that, so what is a block copolymer? In case of block copolymer, sorry, and please mute yourself. Okay, so in case of block copolymer, what needs to be happen? If there are two kind of monomer, A or B, suppose in case of this A is this red one and B is this green one, then to be a block copolymer, so first there have to be one kind of monomers incorporation. Like first there will be only red ones and after that there will be green ones. The opposite also can happen, that one monomer will be consumed first fully and then the second monomer will start consuming. So you will get two different blocks. So this will be one block and this will be another block. Only in that case we can say that this is a block copolymer. Now instead of A and B, if there is another third polymer of some other color, then there will be another block here. Okay, but those blocks will be separated, they will not be mixed like this as it is shown here. And what happens in the other cases? So the block copolymer option is not correct. In the next option, if we skip this, the correct answer you already know, random. In case of alternating polymer, what happens? One red red monomer will be incorporated, another green one will be incorporated. So the next one will be R and the next one will be G. So alternatively they will be incorporated in the polymer. Only in that case we will say alternating copolymer. And graft copolymer, so this option is also not correct. And the last option is obviously graft copolymer is completely a different thing. Graft copolymer means when there is a backbone chain from which there will be dangling chains here and there. Okay, so what is the difference between here? What is the, let me correct it once again. So let me draw. If this is the backbone, in case of graft copolymer, pen, no color option, highlighting color, let me change it something to for you to see. Okay, so in graft copolymer the structure is kind of like this. So why am I drawing this in different colors? Because in case of graft copolymer this is very important. Professor Dhara has already told you these things, but this if somebody has any problem in understanding, let me clarify this again. The main difference is the chemical composition or the monomeric composition that the backbone has is different from the dangling chains that are here. So that's why I have drawn them in different colors to make you understand that their chemical compositions are different. Only in that case you can say it as a graft copolymer. Okay, so all those three answers are incorrect. Okay, all those three answers are incorrect. There is only one option left, this is random copolymer, as you cannot find any kind of proper orientation like block or alternate or graph. So obviously the correct answer will be random copolymer. Okay, so I hope with this the confusion, if anybody had any confusion about block, random, alternating and graph, it should be cleared and you should be able to answer the question in assignment 1. Okay, so let's move to the fifth question. So it is stating each of the following attributes can be related to either chain growth or step growth polymerization. What are the attributes? The first one is the product is the isolated polymer, high molecular weight only at very high conversion, no byproduct formation, no initiator needed, predominantly carbon backbone. Now you have to separate them, that which are the features for step growth polymerization and which are the features for chain growth polymerization. There are 4 options. Now you have to classify them, that which of them are true for step growth and which of them are true for chain growth polymerization. Okay, so try to think it out. I will give it as it is a kind of a big question, so I will give you 3 minutes or so. Try to solve it by yourself, and then I will check the chat box, and then I tell the solution. Try to remember the properties, that what are the difference between step growth and chain growth, and then you'll be able to answer this question. You can write down the questions as well, because I have to go back to the main screen to admit those who are trying to join now. So because this question is pretty long, there are some features written, so you can just write it down so that I can move to the main screen. Okay, so let me go back to the main screen. Let me look at the, okay, somebody has answered C. Okay, okay, someone has answered D. Okay, okay. The chat box is open for all. I can check the answers, as it's just MCQ. I can quickly check all the answers. So everybody is free to answer. Only some people are answering. Uh, okay, that's fine, but anyone can answer. It doesn't matter if it's wrong. I am here to correct it after all. Okay. So mostly I have seen the answers as C. Someone has said it is D. Okay. So let me go back to the slide and explain it. Okay. So the correct answer is C. So let me come to the points one by one. So the first point is the product is the isolated polymer. So whether it will go to step growth and chain or chain growth, what it will depend on. In case of step growth polymerization, one second, we know that the polymerization is not like a consecutive one. Like in case of step growth, a dimer, trimer, or a tetramer, or more on like this, they are forming at the same time. Okay, so they are at a certain moment, there are monomers present, there are dimers present, there are tetramers, pentamers, everybody are present at a certain time. So in case of that, what we get, the overall reaction is the product. After the reaction is done, the whole system is our product. We are getting a mixture of many kind of, say, in mar, I'm just sorry, I'm very bad at writing by using this pen. So suppose we are getting in mar, n plus 1, then there are n plus 2. So our entire reaction mixture is our product in case of step growth. But what happens in case of chain growth polymerization? So here is the active site, or say the radical. So one monomer is attaching, second monomer is attaching here, third monomer is attaching here. So all the chains, so suppose there are 5 radicals present in case of chain growth. In all case of, for all of them, the monomers are adding consecutively. So the monomers are coming here and adding into this one. So this way the product that we are getting gets isolated from the reaction mixture. So we don't consider the whole reaction mixture as a product. So the first point that was given, that product is the isolated polymer. So this is because of this mechanism that they are adding consecutively. So this is the property for chain growth polymerization. That is one. Next one is high molecular weight only at very high conversion. So if we think of step growth polymerization, so as I already said, that a dimer, monomer, tetramer, pentamer, everybody is existing at the same time. So obviously the molecular weight of a dimer will be much less than the case of a pentamer or hexamer. Okay, so in case of that, obviously we will not get a very good or high molecular weight at low conversions. If we look at the graph, then we can, sorry, if this is molecular weight, again pardon my handwriting, this is very bad, I am not accustomed to write in slides. And if this is conversion or rho, then we can only see that initially, as every type of monomers, dimers are existing, so the whole molecular weight cannot be very high because it is not forming a single or a big polymer. So only at high conversion we can get, the curve will be more, will be like this. Okay, only at high conversion we can see a growth of the molecular weight. Like suppose at the in the 99% conversion, now there are maximum number of pentamers or hexamers. I'm just talking about a small polymer chain. Obviously that will be in number. So there are some mainly hexamer or pentamers, so they are now coming and joining to each other. So only at the last stage we are getting the highest molecular weight that we are actually wanted. But in case of chain growth, what happens, as there are consecutive addition, so in case of chain growth we can get a high molecular weight at a very low conversion, because they are not randomly attaching to any monomer, they are attaching to that place where the active species or radical is present. So in that case we can get a, in case of chain growth we can get a high molecular weight at very low conversion. So the point was that, second point, high molecular weight only at very high conversion is applicable to step growth polymerization. Next is no byproduct formation. Obviously that is the property for chain growth polymerization. Most of the time it happens via addition reaction, because if you think of it, in case of step growth we don't need an initiator, so the functionalities are actually interacting with each other, and every time suppose COOH or NH2 or COOH or OH, these functional groups are reacting with each other, we are getting a small molecule that can be said as byproduct. But in case of chain growth we are dealing with some radical molecules where the monomers are consecutively attaching, so there is no question of byproduct formation. So the third point, no byproduct formation, is valid for chain growth polymerization. Now coming to the fourth one, Obviously, this is very obvious. Step growth polymerization happens via the reaction of functional groups, as I have already said. So in that case, we don't need an initiator to form a polymer. So that goes for step growth polymerization. And the last one, that is, it is a predominantly carbon backbone. That is true for chain growth. And in case of step growth, mostly there is a heteroatom because there are different kind of functional groups. Obviously, functional groups means NH2 or COOH. Only in case of this we get a nitrogen atom, or suppose a SO3H group or something. So in case of this nitrogen and sulfur atoms, these are the heteroatoms that are mainly present in different kind of functional groups, and functional groups are obviously used in case of step growth polymerization. So in case of chain growth, we generally don't need any functional group to react. So generally we just have this C double bond C bond attached to any kind of molecules. So they just react with the radicals. So in case of that, generally predominantly we get a carbon backbone. Okay, so the last point goes to chain growth polymerization. So let's move to the sixth question. Okay. So this is the sixth question. This is a very easy one, a very short question. So I will just give you 1 minute to answer this. So this is the structure of this polymer, and they have asked us the IUPAC name of this polymer. So you just have to know the IUPAC name of the structural unit, and then you can just put poly in front of it and you will get the answer. Okay, I will just keep 1 minute and then check the chat box. You can draw the structure because I have to move back to the screen to admit. I think still many people are trying to join the meeting. Someone is saying A. C. Okay, A and C. I am seeing mostly A. Okay, I am showing the question again. Polypropylene. Okay, let me show you the question again. This was the question. So who was asking, please write down the structure, so that way it will be easier for me to go back to the main screen. Okay. I think you have wrote it down. So I was mainly getting A and C. Some answers were C as well. Okay, let me go back and see. D. Okay. A, C, D. So I am getting kind of a mixed answer this time. C, D. Many answers. Okay. D. Okay. Okay, so let's go back to the question and let's see what is the correct answer. So the correct answer is D. So this is the polymer structure. So many people has some people has answered C. No, I think they have confused. So what was the convention for naming these polymers? One second. So first you have to write poly. that was the convention. And then whatever is the IUPAC name of the structural unit, that you have to write inside. Okay, so obviously these are not the correct conventions at all. Okay, so these two are crossed at the first place because this is not the correct convention that was mentioned. So we know either A or C will be the correct answer. So what is the structural unit? What is the monomer that it came from? That is CH3. Again, pardon my handwriting. CH double one CH2. So this is the structure of the monomer that is being used, because see, there is this double bond which is getting polymerized simply, right? So this is the double bond, this is just a side group. Okay, so this is not taking part in the polymerization, you can see it already. So this is the backbone, CH bond CH2. So if this is the backbone, where you have to put the double bond between these two carbons, so this should be the structure of the structural unit. So what it is, IUPAC, this there is 1-methyl ethylene. Okay, that is the name. So you just have to put it in the bracket. So the correct answer will be poly 1-methyl. So this is 1-methyl ethylene. That is the answer. Obviously this is the convention for IUPAC name. So this is your double bond, here is a methyl group, so you have to start numbering from this carbon obviously. So the methyl group is in one position, so 1-methyl, and this is this ethylene, so poly 1-methyl ethylene or ethylene. Okay, so let's move on to the question number 7. Okay, this is a general question, try to answer it, but it's I will say that this is not much important for your exams, because this is just to show you the applications of the different kinds of polymers. Try to guess their applications. So there is given a column 1 and column 2. You have to match that for what purpose bakelite is used, for what purpose low density polyethylene is used, and so on. You just have to match. Try to find out a match about this. This is nothing like a scientific question, it's just like a application of different kinds of polymers, just to have a common understanding that in what purposes they are used. So this is nothing for the exam purpose or assignment purpose as well. Okay, try to do it. As there are many options, I will give you 3 minutes to solve this, and then we'll see the answer, correct answer. Okay, if somebody has any question, I will give you time. You can write it down during the break of 10 minutes that I will give after 1 hour, and there I can see the question, and I will then discuss them. Okay, because otherwise I have to constantly go back and check the questions. let's go back and see what others think that the answer is. I'm very sorry. Some has said A, okay, okay. Okay, someone has asked, I can see the right answer is polymethyl ethylene. Okay, so according to IUPAC name, IUPAC, in case of IUPAC name, we do write 1-methyl ethylene. We have to mention the numbering. So it's just for that. Otherwise, you can write polymethyl ethylene as well, because many times like propanone, we said like propanone, like this kind of things. But just to show that the numbering was there, I just wrote that poly 1-methyl ethylene because that was the option there. That's why I just explained it. Okay, so most of the people polypropylene. So how how would it be the polypropylene? Okay, I said the IUPAC's name. Just see the convention. There are two kind of nomenclature that has been mentioned by professor. So one is the trivial name, that is in generally is used. The question was not asked about the trivial name, it has asked the IUPAC name. Okay, that's why the answer is the poly 1-methyl propylene, because they have asked for the IUPAC one, they haven't asked for what is the trivial name. Okay, like we say that PVA or everything or PET, these are the trivial names, but what they have asked here, or say PBA, we kind of say the short names or trivial names, but that is not what they have asked. They have asked us to the IUPAC name, that's why I have said. Okay, let's go back to the question and see what is the correct answer. Okay, so the correct answer is A. So all of you are correct. So the first one is very easy actually. We all know for what bakelite is used, that is for electrical switches, we all know that. Next comes this low density polythene. So the low density polythenes, they are very easy to mold into anything. They are kind of I mean, you can mold them in anything like thermoplastics. So obviously these kind of materials are used for these squeeze bottles. Next is this melamine formaldehyde resin. They are used for this unbreakable crockery. Nylon 6 is also, most of you know that they are the main components of the tires. Actually, tires, you everybody know that nylon 6 is used. Next is the poly tetrafluoroethane. That is the coating that you also know that is the coating that has been used for non-stick cookwares. And the last option is polystyrene, as it is a very good uh, uh, it is a very good material for packaging and for shock absorbance, because it's a good insulator. So this kind of materials is very good for packaging material for shock absorbance. Okay, so this was just a very common questions about the applications. Let's move into the next one. Okay, so this is a very good question again. So it states the polymer sample having low modulus and large strain at break is best described as, there are four options: a brittle plastic, a tough fiber, an elastomer, a plastic with yield. So to be able to answer this question, you just have to refer the graph that has been showed by Professor Dhara, that is the stress versus strain graph. If you look at that, you can easily answer this question. It states that it has a low modulus and a large strain at break. Okay, I will give you like it's already 8:02, so I will give you 1 minute to think of it, and then I will check the chat box to see what answers you are giving, and then I will get back to you. C, most people are answering C. Okay. Okay. C, plastic. Okay. Elastomers. Okay. 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 So let's go back to the question and see the correct answer. Okay. So the correct answer was the elastomer. So as I said that to answer this question, you have to look at the stress versus strain curve. So this is the stress versus strain curve. So Professor Dhara has already discussed all these things. But let me again say this. So they are saying that this polymer sample has low modulus. So what do you mean? Do they mean by low modulus here? That is, they have a low Young modulus actually. So what is mainly the equation is sigma is equal to, suppose, E epsilon. This is the Hooke's law by which this stress versus strain curve can be actually is plotted. So this is the Young modulus. So we can obviously say it is nothing but the slope of this stress versus strain curve. So here it is said that it has a low low modulus. So it obviously means it will have a very low slope as well. So in case of this graph, obviously the low modulus is here for the elastomer, and the second point is a very large strain at break. So here is the break point and here is the value for strain for elastomer. So for elastomer only it has the highest strain value at break. So what does this strain usually means? It's nothing but the elongation. So you are generally putting a force, that is the you are generally elongating something, so that is creating a particular force per unit area, that is nothing but the stress we are talking about. So whenever you're trying to stretch something, so there will be a strain or elongation that will be created, and by this equation we get the, by Hooke's law, and by this equation we get what is the stiffness of this material. I mean, the lower the slope, the more flexible it is. As you can see here, the low modulus, low Young modulus means, one second, low Young modulus means it is much more flexible, that you can actually elongate it for a longer period. I mean, it can hold on a very high amount of stress. You can elongate it, and after that it will get deformed, and that is called the break point. After some time, when you are stretching a elastomer, means you are stretching it to a point, you are getting a good elongation, but after some point the stress will be too much for it, when the material will be deformed and you cannot take it back to its original state again. So from these points, that it has a low modulus and large strain at break, we can say that it is nothing but an elastomer. So you people also have a similar question like that in your assignment as well. So I think now you will be able to answer it. You just have to say see what is said about its Young modulus, whether it's high or low, or what is stated about its strain at break. uh, all these different class has different strains and different modulus, so by that you can differentiate them. Okay, so it is already 8:07, so I will give you all 10 minutes break and then we will get back to the session. So what you can do that, the doubts that you have, whether from the lectures or the question that I have been discussing, you can write it down in the chat box, and after 10 minutes I will be back in this session. I will try to answer the questions or doubts that you have. If I know them, I will definitely answer them, and also we will now move to the numerical types questions as well. I think, okay, oh sorry, okay, there are some question. After that we will move to the numerical types questions as well. Okay, so now it is 8:08. We will be exactly back at 8:18. Okay, at 8:18 we will be back, and I will then discuss other questions and other numerical problems as well. And there were some questions from some students mailed our professors in the SWAM portal. I will discuss them as well. Okay, thank you. You can take a break and write down your queries in the chat box. We will be back at exactly at 8:18. You don't need to leave the meeting. You can stay in the meeting. Okay. Write down your queries. I will answer them after 10 minutes. Okay, so it's 8:18 and let me resume the session again. So I have noted down your questions. I will answer all of them, and most of your question will be answered in the next few examples as well. Okay, so let me go back to the questions that we are discussing. And okay, we have discussed this one. This one is done as well. Okay, let's move to the next question, that is question number 9. So as we have to move do some numerical problems as well, I will give you less time in this kind of question and I will discuss them quickly so that we can spend more time on the numerical type questions and the doubts that you have asked. Okay, so this is the ninth question. It states that for a protein sample it was found that the viscosity average molecular weight mv was equal to the number average molecular weight mn. Among the following relations, the correct they are asking what is the correct answer. So there are 4 options given. You just need 10 or 20 seconds to answer these questions. Try to think. After 30 seconds, I will check the chat box and then I will discuss this question as well. Okay. Okay, so let's see what everybody is answering. Okay, so everybody is answering C. Okay. Please mute yourselves. I am currently unable to do it. Please everybody mute yourself. Okay. So many people are saying C. One option is B. Okay. So let us check the answer. Okay. So the correct answer is B. So it was a easy question because see, they have written that the mv is equal to mn. The only condition in which case any two molecular weights will be equal to each other if the PDI is 1. Okay, that is, it is a monodisperse polymer. Only in that case any two kind of molecular weights will be average molecular weights will be equal to each other. As they have already stated that mv is equal to mn, so obviously it is a monodisperse polymer. So as it is a monodisperse polymer, so there will be no difference between them. What is the meaning of monodispersity? That they have all have the equal molecular weight, they have all the same number of monomers, same chain length, same molecular weight. So that means they will all have the same number average molecular weight, same weight average molecular weight, same viscosity and same Z average molecular weights as well. So whenever you see that it is stated that two molecular weights are same, that means it is a monodisperse polymer and you can easily say that all the molecular weights will be equal to each other in that case. So let's quickly move to the next question. This is a very easy one as well. I will not go to the chat box for this one, okay, because it is a very easy one. I think you all can answer this. So they have asked that what is the general name of the polymers who have this kind of following group in the main chain. So I'll just give you 10 or 15 seconds to think it out and then I'll show you the answer. You can just check by yourselves that whether you were right or not. Okay, so obviously it was very obvious. The correct answer was option D. It is a polycarbonate. This is a carbonate group, so this is a polycarbonate polymer. The name of the general name of the main chain will be polycarbonate. This is was very obvious, so I'm not spending any more time on this. Okay, this is another question about the common and IUPAC name. So one, you asked about the in the previous question that you told me there are different name which was a common name. So here is the option. They have asked as the common name as well as the IUPAC name of this polymer. So you have to answer both of them. So common name, I think you all know already, because Thara sir has discussed about this polymer many times, and you have to know about the structural unit of this. So if you know the what is the structure of its structural unit or repeating units, so you can also name the IUPAC name of the polymer as well. Okay, I will give you 30 seconds to decide on that, and then I will check the chat box for this. Okay, so let's see what others are answering. Someone is mostly D2. Acha, 2 means I think it's B. D and B. Okay. D. Okay. Let me add them. Okay, mostly people are answering D. I don't know why it is taking so much time to admit others. Okay, so let's go back to the question. So the correct answer was B, polystyrene, poly 1-phenyl ethylene. Okay, so it is just, I think you have just got the IUPAC name wrong. That's why everybody was answering this as D. So this is the pointer option. Let me click it. Okay, so the common name we all know that it is polystyrene, and the repeating unit of polystyrene is this. Okay, so poly 1-phenyl ethylene, because this is a double bond, so this will be the numbering 1 and 2, because this in this position there is a phenyl group, so numbering will start from here. Okay, poly 1-phenyl ethylene. So D1-ethyl phenylene is not the correct answer. It was just to make you confused. 1-ethyl means there is a ethyl group in the 1 position. That is not correct. There is a phenyl group at the 1 position of this double bond. So it is poly 1-phenyl ethylene. Okay. So let's move to the next question. Okay, so this is a very good question that can be important for your examinations as well. It states there were two sets of polymers. Okay, the first set, when you heat the polymers, they are melted and they can be molded into various shapes. That if you have different molds, you can make actually get them into different shapes, and when you cool them down, they retain those molded shapes and they keep their properties as well. Whereas in case of the second set, when you heat the polymers, we see a deformation first and followed by the whole polymer starts to degrade. They are asking to classify those two different sets of polymers depending upon the heating. there is a classification that Professor Dhara taught all of you, that is based on heating how can we classify different kind of polymers. So based on that you have to answer that what will be the first one and what will be the second one. So I think I haven't give any option in this case. I should have put some options in this. So you can just write down that what do you think what will be the first set and what will be the second set. You can just write it down the whole name because I forgot to put options here. Okay. So let me tell you the options as well. There are some options like thermoplastics, thermosets. So those were the classification that were based on heating or temperature. So based on them you can identify that whether they are thermoplastics or thermosets. What are them? Okay. So let me see what everyone's thinking. Okay, let me look at the chat box. Thermoplastic and thermoset. Thermoplastic and thermoset. Okay. Okay. Very good. Okay, so mostly people are saying thermoplastic and second one is thermoset. Okay, so let us go back to the question. Okay, so the first one states that when you heat it, it gets melted and you can mold it. So why it is a thermoplastic? The answers they have said it is correct. The first one is thermoplastic and the second one is thermoset. So what is the basic difference between these thermoplastics and thermosets? For which one we can heat and then cool it down and still it will retain its properties, and in other case it will just degrade and we can't just mold it into various shapes. What is the difference? Because in case of thermoplastics, what is the thing is the chains are entangled with each other. This is true, but they are not covalently bond with each other at any point. So when you increase the temperature, you can actually increase the randomness in the system, and because of that you can increase the distance between them as well, for which they will kind of be in a melted state. So as there are no covalent bond involved in case of thermoplastics, so whenever you are removing the heat or cooling it down, so there is now permanent damage that is happening to this particular type of polymers. You can get back to its original state as well, as they were just like entangled with each other, not like they were kind of bonded with each other. But in case of thermoset, what is happening, we are cross-linking them at different points. So this is the difference. Now what happens? Now the first chain is attached with the second chain at this point and so on. Again the third chain is attached to the second one at this point and so on. This is continuous for the whole polymer system as well. So obviously if they were not attached by a covalent bond with each other, now if you want to just separate them, obviously you can't. In the previous case they were tangled, so you kind of separate them from each other, but in this case obviously it's like you have a rope that you have tied between those two polymers, so you obviously can't separate them from each other. So once you start heating, they cannot just you are increasing the randomness, but they cannot just separate out from each other. So what happens, instead of, as they can't separate out, so at a particular temperature when you keep increasing it, at a particular point what will happen, the bonds that are here, that will start to break. As these bonds are very important for the properties of this particular set of polymers, so as those bonds will no longer be available, so the properties will also be lost. So at a point they will start to deform and eventually they will degrade, and you will lost all the properties of this kind of polymers. So this is our second set, that is thermoset. So okay, so these were the common type of question, general, not numerical type. So let's move to the numerical ones, and mostly you all had queries from the numerical type questions as well. So I think by solving these questions most of your queries will be solved. Okay, so try to write it down, write down the question, as it will be big and again I have to go back to the main screen to see the answers. So please write down the question and try to solve them. I will give you like 3 minutes, 3 to 4 minutes to solve this question. So this question state that the following polymer, this is a PB, this is nothing but PBA, that is made of bisphenol and bisphenol A and phosgene. The number average molecular weight is given as 50,800. Okay, they have asked us to find out the degree of polymerization value of the polymer, and also it is important that they have said ignore the contribution from main group. So you just have to worry about what you are seeing in the screen, only about you have to only worry about the repeating unit that you are seeing here. By explaining this question, your queries about repeating units and structural units, those will be solved. Okay, okay, try to solve it according to your understanding and then I will discuss it. You will have I will exactly check the answer at after 3 minutes. Okay, so try to solve it and then I will see the answers and then I will explain them as well. A little hint for all of you that it is, the polymer is composed of two different monomers, that is bisphenol A and phosgene. Okay, it is not made of a single kind of monomer. So keep that in mind and try to find out the degree of polymerization. Draw the structure of the polymer as well, because you will need that to calculate the molecular weight of the repeating units. Please write them down. Okay, let me see the chat box if anyone has got the correct answer or not, or what answers they are giving. Okay, I think no one has answered yet. Let me see it for 1 minute and then I will start explaining it. N into 25400. Okay, you will get a specific number. Okay, I am showing the question again, and then I will start explaining it as well. Okay, so this was the question. So first let us see the answer. So this is the answer of this question. The correct answer should be in the range of 395 to 405. Excellent. 1 second. Okay. So why? Let me explain you. Okay. So this is our molecular weight. Fine. We have our molecular weight. We know that molecular weight is equal to what is the number of repeating unit, say n, and the molecular weight of that repeating unit. So let me write that down as m0. Okay, so n is the number of repeating units and m0 is the molecular weight of the repeating units. So what they have asked us is the degree of polymerization. Okay, so first let us calculate what we have here. So if we calculate the molecular weight or mass of this particular structure that is shown here, it is 254. It is already written here. It is coming as 254. Now to be very careful here, as I have said, that this polymer is composed of two different monomers, that is bisphenol A and phosgene. So the thing that you are seeing here, it is in bracket. That means the n that you are seeing here, it is the repeating unit. So the molecular weight that you have calculated 254 for this, that is nothing but the repeating unit. Okay, repeating units molecular weight is 254. So what you are seeing here, it is the repeating unit. So the molecular weight of the repeating unit is 254. So from that we can definitely get that what is the number of repeating units there, that is molecular weight divided by m0. From that we can get the number of repeating units. Okay, so let me divide. It will come around, let me do that as well. So 50800 divided by 254. Okay, that is giving 200. So our n, that is number of repeating units, n is equals to 200. I think everyone should be clear up to that this is our molecular weight, this is the molecular 254 is the molecular weight of the repeating unit. So when we are dividing it, we are getting what are the number of repeating units. That is the obvious. 200 repeating units having the molecular weight 254 giving us the final molecular weight of 50800. But the question that was asked here was about the degree of polymerization, not about the repeating unit. So here comes the doubts that you all had, that what is the difference between repeating units and structural units. So let me give you example. First let me explain it and then I will come back to this problem again. Suppose let me draw here. This is one kind of monomer and in color, and this is another kind of monomer. Okay, so now they are coming just like bisphenol A and phosgene. For your understanding, I am just taking 3 of each. Okay, so now they are forming a polymer. So what the polymer will look like? Suppose they will look like kind of like yellow and yellow. So these will be the structure of the polymer. Why they are alternating? Because they have to react with each other's functional group. So one yellow monomer will react with the red one, this one again will react with the yellow one, because they have to react with each other's functional group. So this will be the case of total polymer that we are getting. Okay, so this is the structure of our polymer. Now we can write it down as highlighter লাল, এটা pointer option highlighter, 1 second, in color, এটা this whole 3. So this kind of things are 3. Okay, 3 sets of this we can write like this. So what are the repeating units? This red and yellow things are making one repeating units, right? So we can just abbreviate as this, as red and yellow one as 3. So this is giving us this final polymer. So this is the number of repeating units. Okay, fine, but the structural units is the total number of monomers. So we started with 6 monomers, 3 yellow and 3 red. So that is the number of structural units. Total number of monomers, how many number of monomers were there? So there are 6 monomers, 3 yellow and 3 red. So 6 is the number of structural units, but after forming the polymer we can write them as this, where these are the repeating units. As you can see, the yellow and red, this is the part that is repeating. So the repeating unit is not 6, repeating unit is 3. This is the basic difference between repeating units and structural units. What you see here is the repeating units, this is not the structural units. And in case of degree of polymerization, you already know the degree of polymerization is nothing but the how many number of monomers are forming a polymer. So it should be equal with the structural units. There are 6 monomers, 6 monomers were forming this particular polymer. 6 monomers are forming this particular polymer. So the number of structural units were 6, as well as the degree of polymerization was 6 as well. Okay, but the number of repeating units was 3. So this is the major difference. So we can always write the degree of polymerization. Actually we can write it like, 1 second, stop moving. Degree of polymerization is 2n. Okay, that is what you are getting. 3 into 2, that was the number of your repeating structural units or degree of polymerization. So whatever value we are getting for n, we have to multiply that with 2 to get our degree of polymerization. That was the case for this problem. 3 into 2 is equal to 6. I use this example so that you can understand small numbers. Okay, similarly for this numerical, this will follow as well. We have our number of repeating units equals to 200. We already have that, but the question asked what is the degree of polymerization. So we have to multiply it by 2. So here also 200 into 2. So the final answer, that is degree of polymerization, will be 400. Okay, I think this should clear your queries about the difference between structural units and repeating units. Repeating units is what you see here inside the bracket. Structural units is total number of monomers, and what is the structural unit? That is your degree of polymerization. And always remember this one, that in this kind of case where two different monomers are interacting with each other and forming a polymer, the degree of polymerization is equals to 2n, because two different kind of monomers are interacting with each other. That is another important point as well. That is not for the case where a single monomer is present. I will explain that as well, but for now you have to remember, when two different monomers are interacting with each other, the degree of polymerization is twice the number of repeating units. Okay, I hope this clears your doubts. So let's quickly move to the next question. So yes, here someone also had doubt about, I think this will clear it. Okay, so as we don't have much time, let me see how many questions I have left. Nero, Sholo, okay, 4 questions. So I will quickly discuss them. Okay, I will not wait for the answers. You can solve it in the assignments because we don't have much time left. So I will directly start discussing the questions so that it will clear your queries as well as you will be able to solve the assignment questions as well. So so this problem states a sample of polymethyl methacrylate is composed of a series of fractions of different size molecule. So here is weight fraction and here is molecular weight. They have asked us to calculate the MW, that is weight average molecular weight, dispersity or polydispersity index, and the value of number average degree of polymerization. When I will discuss the solution, I think your all doubts will be cleared. So first let's come to the what is weight fraction. Someone just asked that is number I means xi and weight fraction, number fraction and weight fraction, are they different? Obviously they are different. Number means how many, suppose you are getting a mixture of polymers, so how many polymers have this number of monomers. Suppose how many polymers have 5 monomers, you have a chart here. How many polymers have 6 monomers, then you write a fraction here. This is the number fraction. And in case of weight, how many polymer has, suppose molecular weight of 1000, how many polymers has molecular weight of 2000. So this is how the weight fraction goes. So whatever the basic difference in their formula is, in case of xi or the number fraction, it is basically, suppose ni, I have a very bad handwriting, let me cut it. So suppose I have ni here, okay, this is ni. Suppose this is about I number of monomers in a polymer. This means Ni means that particular polymer chain who have I number of monomer in its backbone. Okay. Sorry. Divided by summation of Ni. So there will not be only because polymers are never monodisperse. I mean synthetic polymers are never monodisperse. You will always have a mixture of polymers. Like in some cases there will be 100 monomers, some cases there will be 120 monomers, some cases there will be 80 monomers attached per chain. So there will be a difference in that. So from all of them you can get the summation, and when you divide them by each of them, you will get the number fraction. This is the number fraction, formula for number fraction. Same is goes for weight fraction as well. That is Wi is equal to, suppose one polymer has a weight of Wi, that is its molecular weight is suppose I. But again, in a system you won't have all the polymers have same molecular weight. That will not happen. Some will have I plus 1, some will have I plus 2, some will have I minus 1, different type of. So you have to divide it by summation of all of them, Wi. So that will give you the weight fraction. This is the formulas are basically same. When you are considering about number, you get the number fraction. Whenever you are considering for the molecular weights, you are getting the weight fraction. So let us get into the solution of this question. Okay, so this was the weight fraction that we are given, and we were asked to calculate MW, okay, PDI and XM. Okay, first we have calculated, I think MN calculation they did not ask, so we did not had to. Acha, for the last part. Okay, first look at the, let's see the first question. They have asked the MW. So the formula of MW is multiplying the weight fractions with their corresponding molecular weights and then having a summation. So first we have to get individuals Wi into Mi. So this is our Wi and this is our Mi. So for each of them we can get Wi into Mi. Okay. So when you get their summation, you get 19,250. So that is your weight average molecular weight by the formula, that is summation of Wi by Mi. Okay. So coming to the next question, that is polydispersity index. So what is the formula for polydispersity index? That is, what is the difference between your weight average and number average molecular weight? That is MW by Mn. I wanted to write D card. Okay. MW by Mn is the formula for your dispersity. So again you have to calculate the number average molecular weight as well. But in the question you have given the weight fraction. So how can you calculate number average molecular from weight fraction? You have this second formula. The first formula is summation of xi mi, but in the question you have provided with weight fraction, so you have to use the formula where weight fraction is present. So the second formula for number average molecular weight was 1 divided by summation of Wi by Mi. So again for individual case we have to get Wi by Mi, Wi by Mi for each case, and then we get a summation of W by Mi, this is, and when you put 1 by summation of Wi by Mi, this is the number average molecular weight. Okay. So I think Dhara sir has already discussed how you get that formula. He has already discussed in the lecture. Even if someone has problem, they can ask. I will try to answer it in mail or in the next session as well. Okay. So now we have our Mn value here. Now we are asked about the dispersity or polydispersity index. We simply have to divide these two, Mw divided by Mn, so that we can get the dispersity value, that is coming around 1.23. Moving to the next one, moving to the next one, the third question that has been asked, the value of number average degree of polymerization. You have to give importance to this term that they have asked number average degree of polymerization. So in case of degree of polymerization, you can easily suppose it is the molecular weight of the whole polymer. I am writing it MWP, and suppose it is the molecular weight of the monomer. You can just simply divide it because it was only a single polymer. Polymethyl methacrylate was just a single monomer, it was derived. So you can simply just divide the polymer's molecular weight by the weight of the monomer, and you can get the what it is asked, degree of polymerization. But you have to be very careful, because they have asked here number average degree of polymerization. So the molecular weight that you have to put here is the number average molecular weight that you have get here 15686. If in the question they have asked us the weight average degree of polymerization, then you should have put the MW value here. M0 value is same for all the cases. Okay, M0 value is the molar mass of this structural unit, that is methyl methacrylate. Okay, so whatever is the value of the molar mass of methyl methacrylate, let me write down the structure. Very bad handwriting again. Okay, I'm trying to draw oxygen, COOCH3. Okay, this is the structure of methyl methacrylate. Okay, so you have to just calculate the mass. So both the cases M0 is same. M0, the monomer's mass is same, but as it has asked us to determine the number average degree of polymerization, we would put Mn. If it has asked us to determine the weight average degree of polymerization, we would have put the MW value. So this is the answer, you will get this. Be very careful about this. Okay, let me quickly go to the questions because there is not much time. Oh, that's not a problem. I will discuss this question. I can discuss them in the next session as well. Okay. The degree of polymerization of polypropylene with a molar mass of 84000 gram per mole. What is the value? Let me quickly show you. It was a very easy question. It has just asked the it has given us the monomer that is used, that is polypropylene CH3 CH polypropylene CH2 so this is the monomer they have given us. This is the molecular weight of the polymer. So this is our M value and our M0 is 42. So we have to just divide it by M0. M is here 84000 and M0 is 42. So we will get 2000. This was a very easy question. They have not mentioned about number or weight. So you can easily go with it. Okay, I think we have to finish the question here. Okay, so this was the last question, second last question, that the following polymer was synthesized from adipic acid and ethylene glycol. You all know this polymer. Find out the molecular weight of the polymer with a degree of polymerization value of 500. Ignore the contribution of N groups in molecular weight. So they have asked us to calculate the molecular weight of this polymer and they have given us the degree of polymerization here. Okay. So let me quickly tell you the answer. So again you have to be very careful that two monomers were used in this case to form this single polymer. So if you look at this, whatever is within the bracket, that is your repeating unit, not your structural unit. So this is your repeating unit because it is composed of two different monomers. So the molar mass of this repeating units, if you calculate, it will come 172. Okay. So what you have to do, repeating units is 172. Let me quickly calculate, and the degree of polymerization is 500. Okay, 172 degree of polymerization, 500 172 divided by 2. Okay, so the repeating units is 172. Now we all know that degree of polymerization equals to 2 into N. Okay, but here what is the value is given here is the degree of polymerization value is given. Now what we can do, this is 172 for the repeating units. It is not for the molecular weight of the structural units. So we have to get the molecular weight of the structural units. How can we get that? By dividing the repeating units molecular weight divided by 2. We can get the number of structural units. So repeating unit has a molecular weight 172. So in that case, the structural units molecular weight will be 172 divided by 2, okay, into 500. So this is the value of the number of structural units, and you know that the degree of polymerization is 500. So there are 500 monomers. So let me write down, there are 500 monomers who have their average molar mass is 172 divided by 2, that is 86. So 500 into 86, I am writing very badly, sorry for that. 500 into 86, that will give you the value of this molecular weight, that will be 43,000. Okay, I have to discuss this question very hurriedly, so I will end this discussion. If you have any doubts regarding that, you can mail it to the SWAM, the normal HPTL site. I will reply to them, and also in next session I will start from this question as well as the one that is left. So I will discuss them I think most of your doubts have been cleared. There was one doubt about step growth. I will discuss that in mail. You can send an email there. I will tell you about that. Okay. So let us end this meeting here. Thank you all for joining. So let me know your doubts, and in the next session we will also show you the answers of assignment 1 and discuss them as well. Okay. There was another doubt that came in SWAM. I did not get enough time to discuss it. Okay, I will discuss. I think after the problem solving you will be able to understand what was the difference between these two. I will again discuss this doubt in the next session as well. Okay. So for now, thank you all for okay, I will discuss this one more time, no problem. I will discuss them as most of you have doubt from that part. So for now let me end it. I will again start from this question from the next session then. Okay, that will be fine, I guess. Okay, thank you very much. Thank you all. You all can leave now and I will stop recording. Thank you very much.